So from the Bradbury landing site, we knew we were seeing a different type of material, one we really haven't seen on Mars before. And we were hoping that as we proceeded to Glen Elg, we would see additional exposures of this type of material that we could investigate further, specifically with the Mastcam 100. If I could have my first graphic, please. So this is the HADA exposure that John introduced you to a few moments ago, and we were just really extremely fortunate to have such an ideal viewing geometry of this material. This is a fractured rock outcrop that has been naturally tilted, and it's just an ideal viewing geometry for the Mastcam 100 to look at the fine-scale textural properties of the rock. When a geologist goes into the field, what they want to do is see a fresh exposure of rock to look at things like the grain size, the shape, the color, and the arrangement of those grains, and that tells you a lot about the formation history of that rock. So with the Mastcam 100, we acquired these images on Sol 39, and I'm going to zoom in on the lower left-hand portion of the screen. What you see is this rock is made up of rounded gravels. There's one circled for you at upper right, and a matrix that's very sand-rich. And these attributes are consistent with a common sedimentary rock type called a conglomerate. Now, the class that is circled is about 3 centimeters across. It's roughly the size of the gravel that I'm holding in my hand. And you'll see that the perimeter has a very rounded shape. It's been worn by abrasion in a sediment transport process. You'll also notice the gravel is sticking out from the rock, and over time, erosion is working on that rock face and liberating some of the gravels, and they're falling down and accumulating on a pile at the base of the outcrop. In the next slide, a second exposure of this very same material we saw on Sol 26 and imaged it with the Mastcam 100, the narrow angle, on Sol 27. And this outcrop's name is Link. You see very similar textural properties that we saw at HADA. Again, very rounded gravels in a light-toned sandy matrix. And again, we have that gravel pile that's adjacent to the rock outcrop. So by looking at the size and shape distribution of the gravels that are not only in the rock outcrop, but those that we infer were liberated from the rock outcrop there on the surface, we can get a good idea of the range of gravel size and shape properties that you see there. In the next slide, we'll zoom in, and there's another one of these rounded gravels that's about 1 centimeter across, so it's roughly the size of a plain M&M. And geologists are interested in rounded gravels because they tell you that those particles have been subjected to a sediment transport process, either by water or wind. And so typically you start off with a very angular rock fragment, and as it's transported, it's bouncing along, interacting with other grains and the surface, and that wears away the edges until you have a very smooth surface, such as you see here in this pebble. And the key components of these gravels that we're seeing here are, one, the rounded shape, but also the size. These are too large to be transported by wind. The consensus of the science team is that these are water-transported gravels in a vigorous stream. On the right of the graphic, you can see a typical stream bed deposit. It's a gravel conglomerate that has gravels of the same size and roughly the same roundness as we see on Mars. And so this is just wonderful ground truth confirmation of this water-transported material that was predicted based on analysis of orbital images.